Hello students, hello viewers, welcome to Senior College Mathematics. Topic of discussion is quadratic equations. If you are in senior college, you are preparing for WAEC, for NECO, for GCE, for NAPTEP, for JAMB, or any other external or entrance examinations into high school, this topic, this lesson is for you. Lesson 10, word problems leading to quadratic equations, part 2. This lesson is direct continuation of lesson 9. So let's take more examples. Number 28, find two numbers that differ by 5 and whose product is 50. Let the two numbers be s and y. Differ here means their difference is 5. So you have s minus y equal to 5. You can call that equation 1. Their product, that is s times y, is 50. You call that equation 2. What we have here is a linear and a non-linear equation. In that case, we have the only option of using substitution method of simultaneous equation. In that method, you always start from the linear equation, that is equation 1. So let's start from equation 1, s minus y equal to 5. So we need to make one of the variables the subject of that equation. So I want to make s the subject, and I have to transfer minus y to the right hand side. So you have 5 plus y. This is the order. Equation 1 produced equation 3. To continue, you have to put equation 3 into equation 2. So you substitute equation 3 into equation 2. This is equation 2. Sy equal to 50. Anywhere you see s, you replace it with equation 3y plus 5. This is what you have there, equal to 50. If you expand the left hand side, you have 5y plus y squared equal to 50. For us to factorize, the right hand side needs to be 0, so you transfer 50 to the left hand side, it becomes negative. And following the highest power of the order of the variable y, we have y squared plus 5y minus 50 equal to 0. To factorize, we try to get two factors of 50 whose sum is plus 5 and the product is minus 50. That can be minus 5 plus 10. So in terms of y, we use the two factors to replace the middle term in this form: minus 5y plus 10y. The purpose is to get 4 terms so that we can group like terms. So the first 2 terms form the first group, the last 2 terms the second group, equal to 0. From the first group, y is common. If you factor it out, you are left with y minus 5. From the second group, 10 is common. If you factor it out, you have y minus 5 equal to 0. Clearly, y minus 5 is common. If you factor it out again, you have y plus 10 equal to 0. Therefore, y minus 5 is equal to 0, or y plus 10 equal to 0, equating each bracket to 0. If you solve the linear equations by transferring -5 and +10 to the right hand side respectively. You have y equal to 5 or -10. So you solved for y. Let's get s. You can use any of the equations, but in equation 3 s is already standing alone. So let's use equation 3. When y is 5, s becomes 5 plus 5 equal to 10. When y is -10, s is equal to 5 plus -10 in bracket, that is 5 minus 10 equal to -5. So thus the two numbers are either 5, 10, that is when y is 5, s is 10, or -10 and -5. So this or that. So that is the solution to that word problem. Example 29. The sum of squares of two numbers is 65, and the square of their sum is 121. Find the numbers. Let the numbers be s and y. From the first statement, sum of squares. That means you square the two numbers respectively and add them together. That is s squared plus y squared equal to 65. So let's call that equation 1. From the second statement, the square of their sum. That means the two numbers are added first before you square it. That is s plus y in bracket all squared equal to 121. So we need to simplify that bracket by expanding. So when you expand, you have s squared plus 2sy plus y squared equal to 121. If you write s plus y 2 times and expand, that is what you will get. So we take s squared plus y squared first, then plus 2sy equal to 121. But from equation 1, s squared plus y squared is what? 64. So we replace this s squared plus y squared by 65. That is what you have here now. 65 plus 2sy equal to 121. So we have 2sy equal to 121 minus 65. Transfer the constant term. So you have 2sy equal to 56. If you divide through by 2, you have sy equal to 28. You call this equation 2. So you solve both equations simultaneously. Solve both equations simultaneously. Okay, so equation 1 is s squared plus y squared equal to 65, sy equal to 28. Both equations are non-linear, but the one we can start from is equation 2, in the sense that if we try to compare their powers, power of s and y in equation 1 is 2, but equation 2 is 1, 1. So equation 2 seems simpler than equation 1. So if we start from it, we also make one of the variable the subject. So I want to make s. To make s, you divide through by y. So s is equal to 28 over y. You call that equation 3. This is the order again. equation 2 produced equation 3. To continue, you substitute equation 3 into equation 1. Let us do that and continue the solving process. So we are to substitute equation 3 into equation 1. So this is equation 1, where you see s, you replace it with 28 over y, then you square it, plus y squared equal to 65. If you square 28, you have 784. If you square y, you have y squared, then plus y squared equal to 65. To continue, you need to clear the fraction. To do that, you multiply through by y squared to clear the fraction. If you multiply the first term by y squared, you are left with 784. If you multiply the second term by y squared, from the law of indices, you have plus y to the power of 4. If you multiply the right hand side by y squared, you have 65y squared. So if we rearrange by considering the highest power of y, you have y to the power of 4. If you transfer plus 65y squared to the left hand side, it becomes minus 65y squared plus 784 equal to 0. This is a special case of a quadratic equation, and we adopt the following procedures in finding the solution. To solve any quadratic equation, the highest power must be 2, but here we have power 4. From the power law of indices, you can write 4 as 2 times 2. We are aiming at power 2. When you do that, you have y power 2 in bracket times power 2 again. See that now? 2 times 2 gives 4. So that for us to continue, you let y squared equal to another variable, say d. So when you put d for y squared in this place, you have d squared. Then if we put d here, we have minus 65d plus 784 equal to 0. So we have a proper quadratic equation. Now, after solving for d, you proceed and solve for y. Let us use the formula method, where you have d equal to minus b plus minus square root of b squared minus 4ac over 2a. By comparison, b is minus 65, the coefficient of d. So you also square b here. This is 4, a is 1, coefficient of d square, and c is 784, the constant term. Then 2 times a, that is 2 times 1. Minus 65 is plus 65. If you square this term, you have 4,225. If you simplify 4ac, that is 4 times 1 times 784, you have 3,136. When you subtract the terms in the roots, you have 1,089 and other terms. So you have 65 plus minus the square root of 1,089 is 33. So everything over 2. Because of the plus minus, you can write that term 2 times. So we have d is equal to 65 minus 33 all over 2, or 65 plus 33 all over 2. When you subtract and add, d is equal to 32 over 2 or 98 over 2. When divided, you have d is equal to 16 or 49. Remember, you are not asked to look for d. We only brought d in to ease the solving process. Now that you know d, you can now solve for y. So let us do that right away. But y squared is equal to d. So when d is equal to 16, you have y squared is equal to 16. To get y, take the square root of both sides. So y is equal to plus minus root 16. That is plus minus 4. When d is equal to 49, so y squared is equal to 49. And that means y is equal to plus minus root 49. That is plus minus 7. You know, in quadratic equation, you always have two roots. That is why we are adding plus minus to the square root of 16 and 49 in order to have the two roots. Let us work with the positive numbers. So from equation 3 now, we need to get s because we solved for y. So this is equation 3. When y is equal to 4, s becomes 28 over 4, and that is 7. So one pair of solution is when, okay, that should be 4 and 7. So it should be, no, the order now. Okay, the order is correct. Order is correct. When y is equal to 4, s is equal to 7. That is 7, 4. Then when y is equal to 7, s becomes 28 over 7, and that is 4. Another pair of solution is sy, that is 4 and 7. Therefore, the numbers are 4 and 7. When you run a check on them, both numbers will satisfy the two equations. Hello. End of lesson 10 and the last lesson in this series of teachings. Thanks for watching and learning. Don't forget, watch out for more from the voice of Petakus. Lastly, if you are not saved, your life is in crisis. To avoid that, you give your life to the one that can save you, and that is the Lord Jesus Christ, and you confess him as your Lord and personal Savior every day of your life. If you are saved already, I tell you, big congratulations. Live righteously and be prepared, because on the last day, some will be taken and some will be left. Take good care of yourself. Stay out of trouble. Study your books. Do the needful at all times. Flee every appearance of evil. Don't defraud others to make money. Use your hands and your brain to work genuinely and legally, and the Lord will bless you. Goodbye.